Hey guys, Igor here. Today we will talk about sharding, by example, of course. So, what is sharding? It is a strategy, a technique of splitting your data across multiple databases. So normally you would have one database, you write all of your data to it and read all of your data from it. With sharding, we have multiple databases, shards, and we split all of our data across them, so each shard holds only a small subset of data. And how we do that? To do that, we need to have a sharding key, which basically is a data based on which we decide to which shard we should go to get our data or write our data to it. And besides that, we have a sharding strategy. It is basically a function where as an input it has sharding key, and as output we have shard number. And we have a few types of those strategies. We are sharding by range or sharding by hash. Mostly those we will explore. There's also, I believe, dictionary or directory sharding strategy, but it's not that commonly used. And why we are doing that? Mostly because of the performance. You can have, if done correct, you can have as many times more performance system as many shards you have comparing to the traditional approach, but it is hard to get there. You need to have equally distributed data across all of shard, but still it is possible. And obviously if you do some sort of queries where you can't use sharding key, you need to ask all shards about your data and then assemble the results, but still it is faster because you can do this in parallel. Okay, having defined it, guys, let's go to the code. What do we have? We have a Docker file with the Postgres, and with this one table we have schema SQL, and we have to-do table. We have three fields: ID, name, and the description. We have a sharding key, which is ID. ID, big integer, will be our sharding key. And I also have prepared a script to run a few of Postgres in Docker shards. So we have three shards basically, and we are basically stopping, removing previous container, and then starting the Postgres shard times 3 in that case. And we are mapping some each shard has different port from 50 50 50 51 50 50 52 50 50 53 and so forth, so that we don't have conflicts. We spin up 3 of those shards. So actually let's maybe do that right now. Let's run it, and we have 3 Postgres shards to which we will write and read data from. And what else do we have? We have to-do record, which represents our to-do table, and we have, most importantly, SQL to-do repository. What do we have here? We have shards templates, and it is a list of JDBC templates. And in that case, JDBC is basically, it is an object from the JDBC Spring library. It will help us to talk with the database. You can treat it, each JDBC template instance, you can treat as a separate connection to a database. So we are connecting here to as many databases as we have JDBC templates. We also have shard resolver, and this is our sharding strategy basically. We are giving it ID, long ID, to-do ID in that case, and it returns us the index of a shard that we should ask. And what else do we have? We have a few factory methods to create this repository based on different sharding strategies. So we have hash shards, range shards. We covered that later. For more important things, we have create method, and it is a simple insert, but as you can see, we need to have we are calling shard JDBC template, and we need to resolve shard. So we are giving it ID, we are using shard resolver, and it returns us correct shard to which we should write the data. Same is true for of ID method, where we are getting to do based on ID. We need to get shard before asking. And we also have all of name like method. And here, based on name pattern, we are getting all to-dos that have matching name based on this like pattern, but we can't use sharding or sharding key because sharding key is ID, and we need to ask all shards in that case. So that's why we are iterating over all shards templates, and we ask in parallel. We execute that query in parallel on each shard. So that's mostly it. And we have sharding app, where we will be testing where we will be doing our experiments. So we have some random things that will help us generate random to do, nothing special here. Random ID, random name, random description. We have 3 shards. We'll insert 100,000 to do there. We have shard JDBC templates method, and here we are just connecting to the shards that we have spin up in the Docker. And we are generating random to-dos. We have hash shards right now, and then we are using executor to insert our to-dos. So let's maybe go to the hash shard, because this is what we'll cover first. So basically, of hash shards, it's creating us SQL to-do repository, but with the hashing strategy configured. So how it works is the same as in HashMap. So we are taking the hash of our sharding key, and we are doing modulo on the number of our shards. And here maybe hash is a little bit redundant because we have int as a sharding key, but still we can have string, and then you need to do that. Okay, so let's run it actually, guys. Okay, we are inserting 100,000 to-dos, so it will take a while. Okay, let's actually connect to our shards in the meantime. So we do docker interactive terminal Postgres shard 0 PSQL Postgres user. We are in the first shard. Let's count our to-dos. Right, we have 31,000. I believe we have finished the insert. So let's go to the second shard. Let's also count to-dos. We have similar number, as you can see, but not quite. It is a little bit different. And let's go to the third shard. Let's also count the to-dos. Yeah, also 31,000, but as you can see, a little different. Okay, So we have 100,000 to-dos split over 3 shards. So if we do something like that, so let's query for a few to-dos. We have various IDs among other things, and right now we are in the shard number 2. So as you can see, the query is not that straightforward because we can't get this data from the first shard. So if you do that, we don't have it, but because we have only a subset of all data in shard number 1, we have another in shard number 3 and yet another in shard number 1, 0 or 1, and here we have this guy, and obviously we have different guys here and the shard number 1. And if we do again select from to do where ID equals that, we have a result, but we don't have this here, and we don't have this here. But if we go back to our Sharding app, let's comment the insertion. If we do repository of ID, and let's do all of them actually. This guy, this guy, and we have something else, so maybe do this guy. Three IDs. So let's add a comment here that we are getting that ID returning that shard. Okay, some strange people are talking something. Never mind. Let's run it. And you can see that this guy we have from 0 shard, second from second shard, third one from also second shard. It's all because we have implemented that code, right? So we have shard resolver. So it's not that straightforward, but there are many performance benefits, as I said. So let's do something different. Let's count all to-dos where name is like, I don't know, %, We have 597 to-dos in shard 3 or 2, in shard 1 603, 0 648. Right now we can use our another method of name you like. Let's give it AA, and we'll have, let's get size. We have 1848, so it is all summed up because, as I said, we are asking all shards in parallel. So let's maybe see also one more thing, is that the IDs should be pretty random. So if we do that, minimum and maximum, it is all over the place from 11 to 99,000 something in shard 0, shard 1 similar, and shard number 2 also. Okay, so that was hash based sharding, guys. Let's do the range shards. So the difference here is that we will split our data. We'll split our data based on the ranges. So we know that we have some maximum number of ID. Here I assume that it is 1 million, and we have 3 shards in our example. And we'll be doing as many ranges as we have shards. So we have from 0 to 300,000 something, then we have 600,000 something, and to the rest. Sure, we will see that here, and then we will decide to which shard data should go, but it will be split based on the ranges, not on the hash. So let's see that. Let's comment that out. Let's run our shards so that we don't have any data, because right now we distribute it in a different way, so we need to do this from scratch. So let's insert that. No. Okay. Once again, because we need to do here of range shards. Okay. Okay, so we are inserting it, and let's check that out in the meantime. 60,000, 16 I mean. So let's wait. Okay, should be done. Okay, and right now if we go with minimum maximum, yeah, it is pretty even, as you can see. I mean, it increases with each shard. Same here, and besides that, it is all the same, but here it is based on the ranges, and in previous cases we have it based on the hash. So let's maybe do select from to do news, something like that. Let's do as previously, some ID from that guy, some IDs from that guy. That, and maybe some IDs from that guy also. Yeah, like that. And obviously our resolver will sort that out. Let's also do the like, maybe for something different, like, I don't know, like AV. Something is wrong. Oh yeah. Yeah, 620. Let's see here. Okay, all summed up. The first guy from shard number 2, second from shard number 1, third one from shard 0, and we have these ranges, as I said, first, second one, the last one. Our max ID is 1 million, so as you can see, it is pretty equally distributed. Okay, so that's it, guys. Sharding explained with the example. All of the code is in the repository as always. So like the video, subscribe to the channel, and I see you in the next one. See ya!